In our discussion of sequences, we're always on the lookout for quick ways to help us determine, to help us calculate, to help us evaluate limits of sequences. And here's a particularly nice way to do that. So this theorem right here, if f is a continuous function, CTS is my abbreviation for continuous, if f is a continuous function, and the limit as n goes to infinity of a sub n is equal to some limit L, then the limit as n goes to infinity of f of a sub n is f of the limit as n goes to infinity of a sub n itself as f of L. So in words, what this is saying here, we can move a limit of a sequence inside a continuous function. So this is going to be a very useful trick for us. So let's just do a couple of calculations here. So suppose that we have, suppose we have a sub n is equal to 3n over n plus 1. So we could say, okay, what's the limit as n goes to infinity of a sub n? 3n over n plus 1. If we multiply, I guess we should say we divide both top and bottom by n. We're allowed to do that. We have 3 over 1 plus 1 over n. As n goes to infinity, 3 goes to 3, 1 goes to 1, 1 over n goes to 0. So the 3 over 1 plus 0 is 3. Okay, so this is where we are right now. That let's have a L is the limit as n goes to infinity of a sub n. So 3 is equal to L. So now let me ask you about this new sequence here. What's the limit as n goes to infinity of e to the 3n over n plus 1? So this might look like a tricky thing to compute, e to the weird looking thing here, but we can move limits inside and out of continuous functions here. So yeah, we can move a limit of a sequence inside continuous function, e to the x. I guess I need to, make the point down here that e to the x is a continuous function. So we are allowed to interchange the order here, e to the limit as n goes to infinity of 3n over n plus 1. And so this is going to be e to the L, e cubed. So this is a very nice little trick. Continuous functions and limits play very well with each other. And continuous function limits play very well with each other in the limit back when we have limits of functions back in calculus 1, and continuous functions and limits of sequences also play well with each other.